Greetings to all young minds. Hope you all are hale and hearty. I, Urjaswata Priyadarshini Gaur, an undergraduate from MBM Engineering College, Jodhpur. And in today's module, we are going to be covering the most important questions from the topic structure of atom, and we'll be targeting class 9th. So without any further ado, let's get started. So the first question is, an atom has an atomic number 12. What is its valency and name the element? Now the approach to this question will be such that we'll be dividing this question into two parts. The first part we will be finding the valency of this element, and then we'll be deducing the name of this element by looking at the periodic table. So let's get started. And before we actually conclude to the solution by finding the valency and the name of this element, I want you all to recapitalize and remember the basics and the fundamentals of atomic number and valency so that you don't get stuck up anywhere solving such problems ever again. An atomic number is the number of protons in the nucleus of the atom. In other words, it represents the unit positive charge carried by the nucleus of an atom. The atomic number uniquely identifies a chemical element. It is identical to the charge number of the nucleus. And in case of an uncharged atom, the atomic number is also equal to the number of electrons. So in short, for an uncharged atom, our atomic number is the number of protons as well as the number of electrons. We denote the atomic number by the symbol of capital Z. And now we move on to the valency, which is nothing but the measure of the combining capacity of the atoms and molecules. And therefore, it is the capacity of an atom of a single element to react and combine with the particular number of atoms of another element to obtain a stable state or a stable configuration. Now in our question, we have been given an atomic number of 12 and we need to find its valency. So let us consider that element with an atomic number 12 and name it as the element X. Now we are going to apply the 2n into n rule to find the valency of X. Now just a brief look at the basic concept. If this in front of you on your screen is the nucleus of the atom, this nucleus of the atom is going to be surrounded by discrete energy shells or orbits in which our electrons are going to revolve. This nucleus is the composition of proton plus neutron, and these electrons which are orbiting in these specific energy shells, if we talk about these energy shells, the nearest to this nucleus is our energy shell number 1, or the n is equal to 1, and we call it the k orbit. Now we move on to the second one, the second shell, which is the L orbit, with n is equal to 2. And then we have multiple number of orbits or shells around this atom to accommodate the number of electrons as equal to the number of the atomic number in case of an uncharged atom. And where n is equal to 3, we'll find the atomic number, the number of shell, the name of the shell to be n, and corresponding to these we can have n and so on and so further with the discrete energy shell units. Now when we talk about this element which has an atomic number of 12, let us try to find out the electronic configuration of this element. Now in order to do so, now electronic configuration is nothing but the distribution of electrons in these energy shells, in these energy orbits that we just discussed. Now as I told you that in the K shell you have an n equal to 1. So when you put this n is equal to 1 for the 2n into n rule of the number, finding the number of electrons, the maximum accommodation in a shell, you find out to be it is 2 electrons for the K shell. And when you find it for the L shell, where your N is equal to 2, you find the number of electrons it can maximum accommodate is 8. Now, we'll take a look at the question again. We had 12 electrons initially. And out of that 12 electrons, we have accommodated 10 into the K and the L shell respectively. Still, we are left with 2 electrons. Now, these 2 electrons are now going to the third shell, which technically is the M shell. If I try to apply this 2NN rule to the M shell where my N is equal to 3, I will find that my M shell can have a maximum of 18 electrons in its orbit. Now, here we're going to look at the octet rule again. The octet rule is a chemical rule of thumb that reflects the observation that element tends to bond in such a way that each atom has 8 electrons in its valence shell. I repeat, 8 electrons in its valence shell or the last shell, giving it the same configuration as the noble gas configuration. And we already know that the noble gas configuration is the most stable configuration. So in this case, we deduce that the electronic configuration of this element is going to be 2, 8, 2. And in order to give this the valence shell an 8, it should be losing these 2 electrons to some other element so that it can have a stable configuration of 2, 8, which is a noble gas configuration. Now, I want you to go back to the definition of valency, wherein we talk that valency is nothing but the combining capacity of atoms and molecules. And by doing this, by combining to the other elements, it is able to achieve a stable state. So if it loses these two atoms to some element, it is going to achieve this stable gas configuration, and hence the combining capacity of this element X comes out to be 2. That is, the valency of this element comes out to be 2. And with this, we conclude with the first part of the question. Now, for the second part of the question, I want you to go and refer to the periodic table. Once we have found out the valency of the element as 2, we can easily deduce the group and the period of this element. In this case, it's group 2, period 3, and the answer to the next part lies in the periodic table. If we refer to the group 2 and the group 3 of the periodic table, which is right in front of you, you will be able to observe that firstly, this periodic table is nothing but the arrangement of elements in the increasing order of their atomic number. So 12 comes out to be here. This is the atomic number 12, and this element is nothing but magnesium. So the answer to the second part of the question comes here. It is magnesium with an atomic number 12. And to be more talking about the properties of magnesium, it is an alkaline earth metal. However, we are not going to go into that details because that is out of the scope right now. So if you go by the fundamentals and have a step-by-step procedure of solving the valency and then finding the group and the period, you will be able to solve all the questions without any difficulties. So go by the basics and you never go wrong. Let's move on to the second question of the module, which is to name 2 elements with the same number of protons and neutrons. Now, before we actually deduce and come to the conclusion of the name of those 2 elements, I'm going to first take you on a tour of what is a proton and a neutron. So a proton, a neutron, and an electron, all 3 are subatomic particles. Specifically talking about a proton is a particle which is represented by the symbol P or P+. It has a positive electric charge of +1 E, where E is the elementary charge, and it has a mass which is slightly less than that of a neutron, which is a neutrally charged subatomic particle. With each of the masses of approximately 1 atomic mass each, you can refer both the protons and neutrons collectively as the nucleons. To better imagine this, I'm going to draw, and you can see on your screen that if this is your nucleus, it is going to be a composition of both protons as well as neutrons, the P plus N, and this is then going to be surrounded by a number of energy shells and a number of energy orbits that we discussed in the previous question as well, in which our electrons will be revolving around this nucleus. So we are clear with the fundamentals, and now it's time to look and to find out which element has the same number of protons and neutrons. Now this can be done in a number of ways. The best way is to look at the periodic table, find out the atomic number, and find out whether it's charged or not charged. And then you can henceforth find the number of protons, electrons, and neutrons at the same time. Also, I want you to have a careful look at the table which is on your screen. You can observe that the element helium has successfully achieved both the protons and neutrons in the same amount. Similarly, you have carbon, nitrogen, and oxygen, which also have the same number of protons and neutrons. And you can also observe the same observation for magnesium, which has all equal to 12. And then you have silicon, where all equal to 14, and so on. There are a lot of examples. We're just taking a few of them. For more examples, you can refer to the periodic table, and in this table also you'll find a couple of them. So with this, we come to the end of the second question, and now let's move on to the third question, which is to name the isotope used for the treatment of cancer. Now, just to have a layman understanding of what is cancer, then cancer is just an overproduction of cells or tissues at very specific sites in the body. And due to this overproduction, you have a number of hazardous effects on the other organs on also, and it may be fatal as well. So we have devised a lot of techniques to cure this type of disease, and one of them is the radioisotherapy. This is the radionuclide or radioisotope therapy, which is also known as the radiopharmaceutical therapy and molecular radiotherapy, is in which a radioactive substance is administered to the patient intravenously, that is inside your veins, or orally, and is taken up by the targeted organ or tissue where this overproduction of cell or tissue is taking place via normal metabolism, and then in a relatively short period of time it starts showing its effects. The radiation effect is also utilized both for diagnostic purposes also as well as the radiotherapeutic purposes as well. Now, the impact of this radionuclide therapy is based on the local radiation impact of a radioactive substance taken up by those cancer cells and is successful in destroying the tumor cells as well. The formation of a combination that is taken up by the tumor and destroys cancer cells is always an individually tailored process which requires expertise in a broad range of specialties. But the commonly used isotope for the treatment of cancer, and the answer to our question is cobalt 60. So cobalt 60 is an isotope of cobalt, and this cobalt therapy is the medical use of gamma rays from the radioisotope cobalt 60 to treat conditions such as cancer. A radioisotope is nothing but an isotope that emits radioactive radiations, and you can also observe that this cobalt has an atomic number of 27. This is the basic element cobalt, has an atomic weight of 58.933 grams. It has a crystalline hexagonal structure. It has an electronic configuration of argon with 3d7 and 4s2, and it is solid at 20 degrees Celsius. You can also observe that cobalt 60 has a half-life of 5.3 years and has a gamma plus beta primary radiation type. So I hope you're able to understand, and now you get the reason why cobalt 60 is most commonly used as in the therapy of cancer. There are a lot of other examples also, but cobalt 60 has less dangerous effects on human, so it's most commonly used. So the next question is, what does this symbol represent? You might have seen this symbol a couple of times in your books as well. So today we are going to unleash of what is this symbol. So this symbol is nothing but wherein this X represents the chemical element that we are going to be considering. It can be any element from the periodic table. This A here is going to be representing the mass number. This mass number is nothing but A is equal to Z plus N. Now Z is something that we have already looked in the previous slide, where Z is the number of protons, or you can say it's the atomic number, and N is the neutron number. And this Z over here is the atomic number, or P, that is the number of protons. And with this, we have finally understood the significance of this symbol, so that whenever you look at it again, you will never be confused. This symbol is going to give you a complete information about a chemical element along with its mass number and its number of protons or atomic number. Now the next question asks us about to draw the atomic structure of an atom with the same number of subatomic particles and an atom with the same number of electrons in the L and the M shell. So before we actually answer these two and draw their atomic structures, first we are going to recapitalize or take a tour of what actually is a subatomic particle. So subatomic particles may be elementary, that is not made up of multiple or other particles, or maybe composites, maybe made up of other elementary particles that have been bound together. If we take into consideration the standard model of subatomic particle research, we find that there are basically four types. The first type will include the six type of quarks, that is namely up, down, strange, charm, bottom, and top. The second type is going to include the six types of leptons, that is electron, electron neutrino, muon, muon neutrino, tau, and tau neutrino. The third type includes the 12 gauge bosons, which are also the force carriers, which include the photon of electromagnetism, the three W and Z bosons of the weak force, and the 8 gluons of the strong force. And lastly, the Higgs boson. Here, we are going to be considering only three of these subatomic particles, that is namely proton, electron, and neutron, because the rest of them are out of the scope of class 9. So, now we come back to the question. The first part of the question asks us to talk about an atom with the same number of subatomic particles, that is the same number of proton, neutron, and electrons. And here you can refer to the table, which was the answer to the second question, which had the details of a lot of elements. And from there, we can easily deduce that oxygen was one of them. Then you can also have helium, carbon, nitrogen, magnesium, silicon. All of them were having the same number of subatomic particles. You can go back and check it out for more examples. And the second part of it, which was to have an atom with the same number of electrons in the L and the M shell. Now, first recap, we have already talked about L and M shell. L shell is the second energy shell around the nucleus. Their N is equal to 2, and it can accommodate a total number of 8 electrons, and the M shell, which is N is equal to 3, so it can accommodate a total number of 18 electrons. So any atom with the same number of electrons in the L and the M shell is argon. Now this can also be found out by the table, or you look at the periodic table and try to find it out. It's very easy. And also you must note that argon is supporting, it is showing, it is exhibiting the octet rule, because its electronic configuration comes out to be 288. because argon is nothing but a noble gas. So now let's take a tour of their atomic structure, which is the answer, the actual answer to our question. Now first have a look at this oxygen atom. It has 8 protons, it has 8 neutrons, and it has 8 electrons. Now this is the nucleus, which is going to be a combination of the protons and the neutrons, and surrounding it are these discrete energy levels or shells with electrons revolving in them. And in this K shell and L shell, we have only 2 shells. The K shell is filled by 2 electrons, and the L shell is filled by 6 electrons. And then we move on to the next electron arrangement, which is that of the argon 40 atom. It has 18 electrons, a total of 18 electrons, in which you can see that the innermost K shell has 2 electrons, and then the L shell has 8 electrons, and the M shell again has 8 electrons, which satisfies the condition of the question and also satisfies the octet rule, wherein if the last valence orbit is filled by 8 atoms, it has a most stable configuration state. And with this, we come to the end of the module on important questions on structures of atoms. I hope you were able to understand the basic concepts, and now you will be applying these concepts to all such questions without any difficulties. Thank you very much. And now keep learning, keep growing. We'll meet in the next module. Thank you.